Okay viewers, I'm on my next meter to restore. This is a Sangamo Western type H.A.T, 750 revs per kilowatt hour, one phase. There's a number there, 6252280, 3 wire, 50 periods, or 50 hertz in other words, 5 for 20 amps, 2 times 230, 460 volts. The first patent is 1926, 263078. The next one is 260494, 1927, but the year where it was made, 1940, NE for Northeast Victoria. And it has a 1/100th dial on it. Let's open it up carefully. Let's have a good look inside it. No anti-tamper seals in this one, so unfortunately the terminal cover is missing. The water slid on one side and flopped up and bolted down here. This is a pretty darn well made meter. This is all cast iron, this. Major chunky meter, this one. Ugh, weighs a ton. I think I can see where Emco and Email got their design from. You can see where the Email would have been inspired to base their design on. So yeah, looks identical. The shape of the casing where it's derived from, the Sangamo. There you go, let's pull this cover off. Bolts off very carefully, very carefully. Smells fresh and new. So clamps to hold the glass in, like brass plate. Those magnet clamps look familiar. Mechanically this would be the same as Boombox Deluxe's Sangamo type HMT prepayment meter. Did like 20 something restoration videos based on it, and this meter is mechanically the same. This body or the stator assembly is all one big bit, and that's cast iron, just like the casing. There's our bit of corrosion in this one, bit of moisture. There's our potential coil. Very well made meter. And there's the gears in there. RR equals 75. This is a 750 revs per kilowatt hour meter. You can see this little green stuff, which I think is corrosion from that brass nameplate getting everywhere. Bit of moisture in this, unfortunately. Very carefully support this so you hold it up right. I've never seen this mechanical setup before though. Drivers that gear directly off the load wheel. Then it goes to this one which drives a register. All brass mechanics in there. It's all your gears. There's 21934 in there. You can see on the edges of those gears, there's on the teeth, there's wear marks. There's brass brass coating on them, and that's because it's from these wear against them all the years. So they're actually steel. They're not steel. Sorry, aluminium, and they've just got coating of brass on the teeth. That's how old this meter is. It's got 4,106.18 kilowatt hours on it. There's our adjuster. You can see the mechanics in there. The dial pointer's all nice and straight. You can see the gearing in there from this side. The actual spiral part I think is over here. There it is in there. Instead of being directly on the load wheel there. It seems to be sitting quite well. Doesn't seem to jam up or rub against anything. There's your adjustment there. Alright, let's wire it up. First things first, I'm going to aim up everything. Make sure it all aims up okay. See if I've got cloth covered wiring in there. First things first, continuity and aim up everything. Make sure it all aims up okay. Just sure it smells bloody. It still smells like varnish, so it doesn't smell burnt. Alright, let's do some tests. Okay, viewers, you're all ironed up and continuity test okay, everything passed. So we've got active and neutral in here. That wire, I traced it back, connects here and here. It's active and neutral in. That'll be neutral out, active out. Phase, neutral, neutral, phase in that order. So I read this thingy wrong. So that's wired up and carefully crank it on the variac just in case I make a mistake, for safety reasons. Once all is good, I'll just test it with a load. Okay, viewers, variac. It's earthed for safety. Alright, we'll turn this on. Very carefully. That's on 0, turn it on. Very carefully crank up the variac. Voila! She's moving in the right direction and she's working. Right. Hook up the right way. No wires are in the wrong spot. No, that's on its mark perfectly. I'm gonna excuse me. I'm gonna set this up correctly on its mark, perfectly on the one there. That way I got a good starting point to do the accuracy test. Alright, on our mark. Okay, this one's on its mark. On that 1/10 dial. Power on. And power on. That 100th dial. So that should go around 1 full revolution, I think. For that 1/10 to move, advance one. There you go, light takes a while to turn on. Load wheel's not even it's got a tiniest bit of warp in it, but it was transported a lot laying on its back. Yep, that's advancing about the same, that little 1/10 dial there. Yep, that one's advanced about the same. It's a bit hard to see because it's being faded off by the sun. Pretty quiet too, no rattling in this meter. The wheel, the load wheel, everything is perfectly centered. No wheel drop on this one. There you go, we're almost halfway. Looking at the 100th dial. That tells you how far that is between the 1 and the 2 and the 1/10 dial. Okay, that one's approaching halfway, that's good. And this one here is too, beautiful. There you go, the shadow behind the light makes it look like it's not, you gotta get it right on. Yep, that's definitely exactly what the MK's got. It's good for small loads having a 100th dial like that. Okay, it's a tiny bit over halfway, and so is that one. Three quarters of the way approaching. That one there is too, but this is also using measuring what's in the potential coil, so you've got to allow for that. So far so good. There we go, it's almost in the middle of that line, so we'll switch off in a minute. Almost there. Power off. It's almost touching it too, you got another 1/100th to go there. So I'll get that little dial back to 0 and see what it does. It's a tiny bit slow, that old meter, might have to be adjusted. So let that get to the 0. Then again, the BAZ's also measuring what's in the potential coil, so we'll unplug the heater and see what the BAZ measures just off this meter alone. Okay, it's got to get to the 0, that 1/100th dial. Spot on 0, unplug. that spot on the too, and that was just a tiny bit off the centre. As you can see there, the ball's not moving at all. There you go. It's about, I would say, not much. It's probably 100 watt, 1/100th of a watt hour on that one there, out of accuracy. That's not really too bad at all. So I can adjust that. There is a little adjuster in there. Alright, let's give a cosmetic restoration on it. Now viewers, rather than just adjusting the damn thing, I could mess something up. These do need to be lubricated. So, that could be why it's lagging behind. Not because it's the adjustment's out, but it could need to be lubricated. Because this has never ever been through the shop like this one here has. 1978 it was last reserviced and recalibrated. This one here, along with many of the other ones, have never ever been refurbished. So it's probably got some dry grease in there that's gummed up and slowing up the load wheel. So I open it up and put a dab of lubricant in the jaw bearings and everything. Then it should be accurate, because it's not slow by much at all. It's a very well made meter. Okay, if it was a tiny little spray of silicone spray in the bearings, in there, that top bearing got some lubrication, and the bottom bearing in there. If I can get the camera to see it. Where is it? Right in there. The cup just sits in there. You can see it's laying on its back, it's not centered. I put a bit of silicone spray in there too, and that should improve its accuracy. As I said, it's only out by the smallest, tiniest bit. There's a very tiny bit there. But that lubrication should help it a lot. So let's put it back together. We can do a little bit more cleaning on it. I'll get the little marks off it there just so it looks really nice. That's a bit shinier now. I'm going to do a little run with the cover off so you can see the mechanics working. Alright, power on. When the camcorder wants to turn its light on. There you go. Yeah, silicone spray got in those teeth. It's probably a good thing to help prolong its life. There's probably other bearings in there I got to lubricate as well. It's pretty dry down in there. That's approaching halfway. That's still a little bit slow. I might need to lubricate this a little bit more. But the main bearings helped. Yeah, the wheel speed's a bit smoother too. It wasn't quite as smooth before. Well, it's halfway. That one's about 3/4 of the way. I didn't start it right on from last time though, so yeah, a little bit. I reckon a little bit more lubrication in these gears. I reckon will help it. Other gear in there. This one is cool, I like this one. And the driver's that one which goes to the register. 197385. At least it's not fast, because that if it's going too fast, that would mean that the brake magnets have weakened. So the brake magnets in this one are still good. Let that get to 0. Yeah, it's about where it was before, exactly advanced from where it was last time. Yeah, it's on the 9. Yeah, it's out by 100 watt. It's out by 1/100th of a kilowatt hour. So it's 1/100th of a kilowatt hour too slow. But yeah, I reckon more lubrication should fix that. But made in 1940, what's that? About 70 years old. So she's doing pretty good. Just about to touch the 3, that one, on a 1/10th dial. And that's exactly where I left off from when I started. From before on that other advance. So it's advanced about the same. So yeah. Alright, put it back together. Okay, viewers. Gave it a tiny bit of a lubricant. Carefully took this register assembly off. This lifts off and slides off. And very carefully spun the load wheel just by hand. Very carefully. She didn't feel too badly stiff, but the grease in there in the bearings just probably turned to gum. So it's definitely original lubricant when the meter was new, so it would have gone gummy over the years. But the silicone spray should hopefully penetrate that after a while, and if she comes good, I shouldn't need to adjust it. There you go. Thanks for watching.